What do you guys want to see? I'm sorry, Anthony, I said I would take your question. I already answered it? Oh, okay. I did record first period. I'm recording second period as well. I'm going to post both videos because a lot of times when I have more than one section of the same class, you guys ask about different things. What do you guys want to see? Whether it is something straight off the review, something from the homework, or you want me to make up another problem that is similar to one off the review. I'm more than happy to do that as well.
Can we do, oh, I'm sorry, I'll wait.
You're fine, no, you're good.
Because I'm not even, like, I was going to say the whole paper.
11, yes. Problem number 11.
I think that's like the only one I did. No, it's a lot.
Oh, there also, I realized there was a very slight typo on the complex numbers question. Express your form in the answer. It said A equals BI, A plus BI. That was not supposed to be an equal sign there. I think that's on, yeah, number 8. This guy right here is not supposed to be an equal sign. That's supposed to be a plus right there. So I apologize for forgetting to hit shift before I hit that key. What'd you say?
I had a quick question about this.
Yeah, go for it.
The question's going to be formatted like this, where it's like 11A, 11B, 11C, or is it going to be like...
They can have multiple parts to them, but I'm not going to give you 11 questions with 3 parts each, because that would be 33 questions.
You know how many questions it's going to be?
You said 13, right?
It's somewhere between 11 and 13. I don't remember off the top of my head exactly.
Is that counting like the A, B, and C parts?
That is not counting the A, B, and C parts, but most of them are straightforward. It's just one question. Some of them have 2 parts to them, but that is not the majority of the questions on there. All right, rationalizing our numerators. Did you guys want to go over all of these or just hit on 1 or 2 of them?
Just one.
Just one of them?
2 of them.
2 of them.
Don't waste time.
3 of them.
There are only 3. Okay. Anytime we are rationalizing, we are going to multiply by the conjugate. Since it is the numerator that I'm wanting to rationalize, I'm going to multiply by the conjugate of the numerator. So I'm going to multiply by 1 plus the square root of 3 plus x. All right. Up in the numerator, because these are conjugate pairs, when I multiply them together, I am going to get something that is similar to a difference of perfect squares. Actually, it is a difference of perfect squares. Yes, ma'am.
Wait, so how do you know which sign you're supposed to change? Because you wouldn't do 3 minus x?
No, it's going to be in between your A and B terms. Yes, sir.
Do you multiply by the conjugate when you're trying to rationalize the denominator?
Yes, only you'd multiply by the conjugate of whatever's on the bottom. Yes, same process, just different starting position. All right, very, very good questions, both of those. We do not change this sign right here. We change the sign in between our A and B terms, because remember, we're doing A plus B times A minus B so that we get A squared minus B squared, because that allows me to get rid of any middle terms that might be there. I'm going to square both pieces. All right, so when I square that first term, 1 times 1, I get 1. I know it's going to be subtraction in between them. Here's where you have to be careful. When I square 3 plus x, I do get, or sorry, when I square radical 3 plus x, I get 3 plus x, but I am subtracting all of that. I need to remember to distribute the subtraction to all of that piece, because 3 plus x is my b squared term here. Down in the denominator, I am not going to distribute this. Remember, anytime we're working with fractions, we want to make sure that our final answers are fully reduced. And if I distribute this, I am not going to see if anything will cancel out. So I'm going to leave it like this for right now. Up in my numerator, I'm going to distribute my subtraction here. So I have 1 minus 3 minus x over this horrendous denominator. Can I simplify anything else in my numerator? Yeah. 1 minus 3 gives me what? -2. So I have -2 minus x.
So you're not distributing the 1? You're not distributing the 1, right?
We wouldn't distribute the 1 because
You're
that's
distributing the negative.
the negative, yes. We're not multiplying by the 1. We are multiplying everything by the negative there. All right. Does anybody see something interesting about my numerator?
There's a GCF of negative.
There's a GCF of -1. Let's pull that out. If I take my -1 out, I would have 2 plus x.
Or if you flip that around, it would be x plus 2.
You are absolutely correct. If you flip that around, that is exactly the same thing as x plus 2.
And we brought out.
And because it's the same thing as x plus 2, what's going to happen? That's going to cancel down here. So I'm going to have -1 in my numerator, and I'm going to have 1 plus radical 3 plus x in my denominator. Before I move on to either of the other ones, what questions do we have about this one? Yeah, absolutely. Let's go look at part C then. I want to rationalize my numerator. So what am I going to multiply by, top and bottom?
X radical
X radical
x.
x plus 8. Top and bottom. So I have x radical x being multiplied by itself. So that would give me x squared times x. This is x radical x squared. That's where I got that from. Minus what? 64. Similar to in part A, I am not distributing that denominator because I'm really hoping that something will cancel. So I have x minus 4 times x radical x plus 8. Up in that numerator, I have x squared times x, which is the same as x to the 3rd. Does anybody notice anything interesting about my numerator? Soap.
Perfect cube.
Yep, difference of perfect cubes. So I'm going to use some soap here. So I need the cubed root of x cubed, which is just x. I need the cubed root of 64, which is 4. So my numerator is going to factor to be x minus 4, because I use the same sign. X squared plus 4x plus 16 over my gross denominator. These two guys cancel out. This is irreducible. That's not going to factor any further, so that is my numerator. X squared plus 4x plus 16 over x radical x plus 8. Do you guys want me to do part B, or do you want to leave that for yourselves?
Leave it for yourselves.
Sounds like a plan. What else do you guys want to talk about or look at?
5.
Number 5 and number what? 5 and 12. All right. 5 first.
It's not funny.
Wow, I think I'm gonna cry.
Evil laugh.
Sad tears.
One of these is harder than the other. Do you want me to show you the hard one or the easy one?
Hard one.
Well,
Hard one.
Which one's harder?
B. B is harder. Not by much. Same basic process.
I don't know.
All right. So I have a fraction minus a fraction over x minus 3 minus a fraction. That is way too many fractions. I'm going to rewrite this in a way that doesn't make my head hurt so much. So I'm going to write out my numerator. X over x plus 2 minus 4 over x plus 2. That's my numerator. It is being divided by x minus 3 minus 6 over x plus 2. If I see it like that, it looks less scary. It means the exact same thing. I like this first one. We have a common denominator here. That makes me happy because I can just subtract my numerators then. So this first one becomes x minus 4 over x plus 2 divided by, and here's where we get a bit of a mess. I need a common denominator here. What should my common denominator be? X plus 2.
So you don't flip it yet?
I don't flip it yet. I will flip it, but because I don't have just a single fraction here, I'm going to have a hard time flipping it. I'm going to get my common denominator first, and then I'll flip it over. So I'm going to multiply top and bottom by x plus 2. And I'm going to do the same thing here with the 3.
Why don't you just multiply the full x minus 3 times x plus 2?
X minus 3. I could do it like that.
You would get the same answer.
You're going to get the same result. We're going to end up double distributing anyway, whether you do it in 2 parts or as 2 different binomials. Yeah, it's the exact same thing. All right, so I'm going to have x times x plus 2 minus 3 times x plus 2 minus 6 all over x plus 2. At this point, if you wanted to flip it, you could, because you have a single common denominator here. I'm going to distribute. So I would have x squared plus 2x minus 3x minus 6 minus 6 over x plus 2. I'm going to shrink my writing just a little bit so that I can fit more on the screen. All right, so now I'm going to do a couple things at the same time. I'm going to combine like terms, and I'm going to flip the second fraction. So I've got x minus 4 over x plus 2 times, this will be x plus 2 in my numerator here, and down on the bottom I'm going to have x squared minus x minus 12. Why am I really happy now that I flipped it? Yep. X plus 2's are going to cancel out. So now I have x minus 4 over x squared minus x minus 12. Can I do any more with that?
Yeah.
Yes, that denominator factors. How does this denominator factor?
X minus 4, x plus 3.
X plus 3, so I can reduce it a little bit more. So what's my final answer then? 1 over x plus 3. Part A is almost exactly the same, except it's not a 1 over. You end up with the denominator that cancels out, and you're left with just a factor in your numerator, which is why I think that one's a little bit easier. Process is almost identical. Number 12 is next, and then Anthony, you had one?
3B.
3B. Okay, so 12 and then 3B. All right. On number 12, big question is how many grams of each should be used? What do they mean by of each? Because this is where my variables are coming from.
The alcohol.
Yes. I'm going to let x equal the amount of the 95% solution. And I'm going to let y equal the amount of water. What do I know, or what do I want out of a final product here? Yes. 400 grams, here's a total volume. So absolutely, I can write an equation describing the volume that I want. X plus Y equals 400. I don't just want 400 grams of anything. What other specific qualification do we need our final product to have? Yes, 75%. I love how you said that. 75% of that 400 needs to be alcohol. So that would be my concentration here.
Alcohol.
Yep, ethyl alcohol. Don't drink it. It's very bad for you. When we're talking about concentrations, we have a percentage and an amount. I need to know how much of this is actually alcohol. So I'm going to be doing percent times amount plus percent times amount equals percent times amount. Just like up above with my volume, I had grams plus grams equals grams. I follow the same pattern on my concentration. 95% solution has a 0.95%, and then the amount is what my variable x is representing. When we said 95%, it's 95% what? Alcohol. How much ethyl alcohol is there in water? In pure distilled water? 0. So 0y equals, at the end, I want a 75% solution of 400. What happens right here that makes me oh so happy?
You get 0,
How much alcohol is there in water? 0, because it's the percent of alcohol in each of these things. Yep. 0y, that just drops right out of my equation, which means I can use this equation alone to determine the amount of 95% solution that I need. What is 0.75 times 400? 300. It's 3/4. What is 3/4 of 400? What is 1/4 of 100?
25? Who said 22? You? Oh, I said 25. Oh.
1/4 of 400 would be 100.
Oh, you said one. You said 1/4 of 100.
Yep, I know I did, because I heard the answers and I was like, that's not what I was going for. I said the wrong thing. So 0.75 is 3/4. Divide it by 4, multiply it by 3. I don't really like dividing by fractions, so I'm going to multiply everything through by 100. It's going to add 2 more zeros back here. 30,000, I know, right? What do I need to do to both sides? What do I need to do to both sides to find x? Divide. 30,000 divided by 95. I'm pretty sure that doesn't go in evenly, but I'm also pretty sure that that reduces. By 5. I know 5 goes into both of these. Up on the top, 30 divided by 5 is 6, so this is going to be 6,000 over, what is 95 divided by 5? How much? 19. Can 19 reduce with anything? No, only other factors of, or only other products of 19. 19's prime. You guys don't get calculators on the test, so I'm fine if you leave your answer like that.
So now we have to find y, don't we?
Yep. How are we going to find y?
You have to put that into the other one.
Yep. So I have 6,000 over 19 plus y equals 400. So So I need to subtract 6,000 over 19 without a calculator, which means I need a common denominator, right?
Just 19.
We're going to need to multiply 400 by 19. 7,600. So y is equal to 7,600 over 19 minus 6,000 over 19, which is what? $1,600 over 19.
I have a question.
Yep.
Okay, so are there, like on the test, should we be prepared for answers, you know, like very similar to this one where it's like, you know what, I've said it like that all this entire time, but you know, like this. You know what I'm saying?
Mm-hmm.
Mm-hmm.
Should you be prepared for them? Always. Now, if I have a lot of problems on the test, and I know you only have so much time, am I going to give you every single problem where it is gross fractions?
Yes.
No.
I have
So
no
like,
idea.
you know how usually it's just a pattern where like you'll just have to put one of the percents with one variable and the other percent with the other variable, but this one is different.
Mhm.
Should we expect that?
You should expect that, yes. Honestly, I think this one's easier because you end up with 0y. So it's actually, other than the fact that we had gross fractions, it's actually easier to solve. Let's finish writing out our final answer. We need 6,000 over 19 grams of what?
I think she would.
Of the 95% solution. And I need 1,600 over 19 grams of water. All right, 3B, and then Lily, you had your hand up. I'm sorry, one more time. It's not pulling up? Interesting, because it pulled up for somebody in first period, so I know it's working. This is the same kind of problem I was having last night. Let me see if I can figure out what's going on. If you guys can't access it, I will just message it to you through Canvas. So I want to make sure that you can open that. Hopefully it's just a Canvas glitch for right now. All right, 3B. All right, so this is a rationalize the denominator problem, similar to what we were doing on, what was that, number 5? Number 11. What do I want to multiply by top and bottom as I rationalize this?
Is it going to be square root of a minus square root of a minus 2?
Yes. Square root of a minus square root of a minus 2. So in my numerator, it's just going to be radical a minus radical a minus 2 over what happens in my denominator?
Okay. So you're going to have an a
Mm-hmm.
plus
Will it be plus?
minus, that's on me.
Yes.
So that's going to cancel out, right?
Our middle terms are going to cancel out, yeah, because we're going to get a squared minus b squared since we're multiplying these two conjugate pairs together.
So you're going to have a squared plus 4?
No,
Is this what you said?
it's the radical that cancels.
So you're going to have a minus 2 plus a minus 2.
So you're going to have a minus 2.
Where's the other a minus 2?
Let's look at it. So we are multiplying radical a plus radical a minus 2 times radical a plus, sorry, minus radical a minus 2. So I distribute those, that's a. This would give me minus radical a minus 2. This part right here is going to be plus radical a minus 2. So that's going to cancel. Huh?
I didn't foil.
Good.
No, I didn't.
Don't foil. When you multiply this piece right here, I have a radical times a radical. Same thing underneath those radicals. So it is minus radical a minus 2 squared, because I'm multiplying it by itself. So the squared and the square root cancel out. So I'm subtracting a minus 2. Does that make sense?
Yeah.
Okay. Why did I put parentheses around the a minus 2?
Because there's a negative sign that you
Yeah,
have to
I am subtracting everything that comes after it. So you have to remember to distribute. Always pop parentheses around things that have more than one part. So down in my denominator, I have a minus a plus 2. So my a's are going to cancel. And it's radical a minus 2 all over 2. All right. I want to see real quick what's up with the Canvas thing. Hopefully we can get that working. I'll pull this right back up. But if something broke, I want to know. All right, it looks like it's just maybe a Wi-Fi thing because it pulled up here. Where did my thing go? Oh, there we go. All right. What else do you guys want to look at? Yes, ma'am. 2F? Yeah. Absolutely. Oh, it's right there on the screen. All right, so we have a cubed root. Be careful, he's hanging out up here, but it's still a cubed root. First thing I'm going to do with this, anytime I've got a fraction with a radical around the whole thing, I am going to split it up into the cubed root of my numerator, so cubed root of x squared over the cubed root of 9y. Can I simplify the cubed root of x squared at all? Cubed root of x squared? Nope. Cubed root of 9?
No.
No. Cubed root of y?
No.
No. Am I allowed to leave radicals in my denominator? We are going to rationalize this denominator.
That's not funny.
So in order to make a cubed root go away, if I had something like z cubed, would that simplify?
Yeah.
That would just be what?
Z.
Z. Cubed root of 7 cubed. That would be 7, right? So this is the kind of thing I'm after. I want something cubed underneath my cubed root so that the cubed root cancels out.
So do you just cube it?
Well, let's look at what we got. I have a y right here. I'm going to multiply that by something else. Y times what would give me y cubed? Y squared.
Wait, pause. Can you reset what you just said?
Yep. I need something cubed under the radical so that it cancels. Yep. I have a y under here already.
So you squared it.
So I'm going to square the y and multiply it with that so that I have y times y squared, because that will give me y cubed.
Are you squaring the entire thing?
I'm not squaring these things. I'm multiplying by the cubed root of y squared.
You can do that.
We have to. We are rationalizing the denominator.
Wait, but this is the one where you only multiply by 1. So you're going to do the same thing on top and bottom.
Yes, same thing top and bottom. Absolutely.
So you can leave out the 9 just like that.
We can't leave it out. I left space for it.
Oh.
But we're going to talk about that 9. Because as I watched several people working on this yesterday in both of my classes, I saw people doing something that's not wrong, but it's going to make more work. And because we're already working with shortened amounts of time, I'm interested in telling you anywhere you can save time. 9 is not a perfect cube, but 9 is a perfect what? Square. Tell me a way that I can rewrite that 9 that will make my life easier.
3 squared.
3 squared.
Oh, wow.
So multiply by 3.
So I have the cubed root of x squared in my numerator. Down in the denominator, that 9 is really 3 squared times y.
You just go backwards.
I think
kind of.
Okay.
I'm
I
rethinking
see.
through this. Because how does that, like, what does that change that I'm going to multiply by? I don't want to multiply by 9 squared.
It's 3.
Multiply by 3. Because 3 squared times 3 is what?
20.
27. What's the cubed root of 27? 3. 3 squared times 3 gives me 3 cubed, which will cancel out with my cubed root.
And we don't worry about the x.
We don't worry about the x. I am allowed to have radicals in my numerator unless the directions say otherwise. So I'm not worried about the x at all.
Will we have to rationalize the
Who's-
numerator and the denominator?
It's not possible to rationalize both.
Oh,
So that's a great question. You could only rationalize one or the other, but not both.
okay.
So now we have
So up in my numerator, I have the cubed root of 3
x squared.
x squared y squared.
Okay.
Down on the bottom, when I multiply these pieces together, I'm going to have the cubed root of 3 cubed y cubed.
So 27.
So 1.
Y.
Not 1. What's the cubed root of 3 cubed?
27.
3. What's the cubed root of y cubed?
Y.
Y.
Wait, hold on.
Yep.
Hold on.
So we did nothing to the numerator, right?
The numerator had some stuff multiplied to it. It is now 3x squared y squared.
But now on the denominator is going to be 3y, right?
Yep.
And that's it, right?
That's it.
Oh, wow.
I'm done.
Oh, so you just took a bit of it.
Yep.
How easy? That's easy.
Good. That's what I like to hear.
Why?
No, it's not. I just should have lied to you. I'm sorry. I don't know why I do that.
You know what?
At this point, I just lied a lot. Where am I going? Fifth period. It's third period. Why?
Can we do something on 7?
Yeah, absolutely. Number 7.
Like, honestly, E.
7E. Sure.
Wait, no, I might have just lied to
Oh,
you.
okay.
Do you want to do another one that's like that?
Is there like a harder one?
There's another one that is similar to that I think is harder.
Which one?
It is towards the
Are you
end.
talking about 10D?
Yep.
Because that one's not bad, I don't think.
I think 10D is harder than the one that you were looking at.
Be real.
But like, I get how to approach this one.
All right.
Okay, can we do 10A?
Sure. 10A. I'm going to approach this one the same exact way. Yep, use substitution.
I don't remember that.
Let u equal this guy right here. U equals x squared. Then u squared would be x to the 4th. So I can rewrite this as u squared plus 15u minus 16 equals 0. That's something I can factor. Multiplies to negative 16, adds to a positive 15.
16, 1. I mean, negative 1.
16 and negative 1. So u plus 16, u minus 1 equals 0. So u equals negative 16, u equals positive 1. We were not asked to solve for u, though. We were asked to solve for x. So I have to resubstitute now. U is the same thing as x squared.
I lied.
And now what do I do to get x all alone?
You have to
Square root. When we square root something as part of our solving process, we get how many answers? 2, positive or negative. What's the square root of negative 16?
Plus 4i.
4i. So I have plus or minus 4i. And plus or minus what? 1.
I have a question.
Yes.
So for C on that page,
Mhm.
would you start off by multiplying the exponents by negative 1?
Nope. I would do u substitution again.
Again?
Yep. I would let u equal x to the negative 1.
So on the test, is it gonna, like, are you gonna tell us how we have to solve these?
Nope.
So if I didn't, but U would be the smartest way. I shouldn't multiply.
U,
by
yeah,
negative
U is the smartest way. If you look at something, you're like, that looks a whole lot like a quadratic, but confusing, U substitution.
even for like B. So I shouldn't.
D, I would absolutely use U substitution here. Yes, sir.
When you have like I to the 8th, I would always forget. Do you separate it into I plus I, like I squared plus 4 or 6, I 6, or would you do like multiplication?
On this one, I to the 8th, I would say that that's I to the 4th times I to the 4th, or I to the 4th squared.
Okay.
Because anytime I have I to the 4th, that's 1.
Yeah.
I like getting them to the 4th powers. Yes, ma'am. Check your answer. Anytime you have taken anything to a even power, so if you squared both sides, if you took both sides to the 4th power, if you took both sides to the 6th power, that's actually, D gives me a great chance to look at that. Why don't we look at D real quick? On this one, I'm going to subtract 5x to the 1/4 from both sides. X to the 1/2 minus 5x to the 1/4 plus 6 equals 0. I'm going to use my U substitution, let U equal x to the 1/4. So then I would have U squared minus 5U plus 6 equals 0. How does this guy factor? Yes. I have -2 and -3, U minus 3, U minus 2. So U is equal to 3 and U is equal to 2, but we were letting U stand in for x to the 1/4. How do I get rid of a 1/4 power? Yes, we're going to take it to the 4th power. This right here, if I take something to an even power, you have to check. If you take it to an odd power, you do not have to check. It's a good idea if you have time, but you don't have to. So I would get x equals 81 and x equals 16. Because of time, I don't think I can go through that whole check, but you would absolutely need to check those. You're welcome. Yes.
So when you're doing a problem like this,
Mm-hmm.
and you get to here, I always find it here.
That's not right.
1 times.
You have to FOIL it.
Oh, that's what I keep forgetting.
Mhm.
I have a question for
Yes.
14.
Mhm.
So when I looked at the answer key, you have P equal to 20.
Yes.
Like, would you do that with like big numbers, like? the
So
thousands?
that's a great question. Guys, if you look at the very, very, very last question, they are measuring the population in thousands here. So if P equals 1, what is the population? Yes. So down at the bottom, when they say, when will the population be 20,000? I'm not going to use 20,000 for P. P, they are counting in thousands, so I'm going to cut those zeros off the end and let P be equal to 20. I'm only doing that because they told me they were counting P in thousands. Yes, ma'am.
Question. So for this one on the percentage, you could just multiply times 100 and get the right answer.
Mhm.
Because I keep on solving and I get 24 and the right answer is 40.
All right, let me look at that.
And I looked at